So let's take a look at this question. The question says, calculate the tension T at A, the tension T at B, given the acceleration in the system is 2 meters per second square, assuming there's no friction. So based on our previous video, you can see we established three equations, one for the tension at each point on the pulley system. And then at the end of the day, we also established the formula for determining the acceleration of the system. So let's go ahead and work with the same principle again on this to find the tension on the 2 points as established. So to get the tension at A, we know that just have to draw the free body diagram at A. So at point A, the mass is 10 kg. Following the arrow, you can agree with me that the acceleration is moving in this direction. This is the direction of the acceleration, which means this weight is heavier than whatever weight that is pulling it in the opposite direction. So from what we know here, weight acts downward. But because this particular mass rests on an inclined plane that is inclined at an angle, we have to get the vertical component of the inclination. And the vertical component of the inclination is going to be the weight sine theta. So if we put that together, we already know that the tension is acting upward. So if we are going to get a resultant effect of the system, the system at point A, we will notice that all we need to do is to remove the tension force from the weight acting downwards so we can get the resultant of the system. So to do that, we say the weight component minus the tension, that will give us the system, that's the resultant in the system. So when we expand that, the weight is the mass multiplied by acceleration due to gravity. So which we are going to put that. So the mass, which is the mass, let's call this one M1 and let's call this M2. So the mass M1 multiplied by gravity sine theta, that's the weight component with W sine theta, minus the tension, that will give all the resultant, which is M1 multiplied by acceleration in the system. So if we make T the subject formula, we'll have that M1G sine theta minus M1A equal to T. So when we put everything together there, we have that our tension at point A will be equal to, what is our M1? M1 is 10. Acceleration due to gravity, we're going to assume that to be approximately 10. It's 9.8, we can assume to be approximately 10. So that will be multiplied by sine of the angle. The angle here is 30 degrees minus the M1 is still 10, multiplied by the acceleration in the system, which is 2. So when we simplify that further, 10 multiplied 10 is 100. 100 sine 30 will give you half of it, which is going to be 50. So our final result will be the tension at A is going to be 50 minus 10 times 2, that is 20. And when you do the subtraction, the tension at A is equal to 30 Newton. So that is it. Simple as that. Now let's determine the tension at B. Feel free to pause the video and try to find the tension at B. So to find the tension at B, we'll do the same thing. The system, the free body diagram of the system, we have 5 here, 5 kilogram. That's the mass. And from what we know, the force that are acting on this mass include the weight, which is pulling downward under the influence of gravity, the tension that is pulling upward. But according to this, the one with the upper hand here is the tension, because that tells us the direction of the system. You can see that the entire weight is moving upward, despite, regardless of the weight of the 5 kg, they are all heading upward as a result of the pulling effect generated by M1. So that is it. So the upper hand is T, so which means the resultant can be obtained by subtracting the weight, which is acting downward, from the T. So it means the tension at B, if we subtract the weight acting downward from it, we'll get the resultant, which is the mass m2 multiplied by what? The acceleration of the system. So when we expand that further, we have the tension at B minus, what's the weight? The weight is m2 multiplied by G equal to m2 multiplied by A. So when we break that down, we have that the tension at B is going to be equal to m2A plus m2G. So we can now have something like this. TB will be putting everything up. We have m2 is 5 multiplies the acceleration, which is 2, plus m2 again is still 5, multiply acceleration due to gravity, which is 10, and then we will have the tension at B to be equal to 5 times 2 is going to be 10 plus 50, and we have 60 Newton. So, however, the tension at A and the tension at B includes 30 Newton at A and 60 Newton at B. And that is the final answer. Bye-bye.